All right, so now that you've hopefully gotten an idea in your head of what's going to happen to the size of your interval, the amount of air you're allowed to have whenever your confidence increases, now we're going to go ahead and formalize it just a little bit. Okay, so first of all, the most common probabilities for a confidence interval, which I will be abbreviating CI, are going to be 90%, 95%, and 99%. Okay, now, historically, those are definitely the most common ones because, again, we had to do calculations by hand for years. Now, with calculators and computer systems being able to calculate those pretty quickly, it is not uncommon to see other levels of confidence come into play. Okay, but again, typically and historically, you'll see a lot of 90, 95, and 99% confidence. So again, here we've got a little diagram, and this is just kind of the statistical side of explaining what we did on the dartboard and our little guess a number game. Notice that as you have this 90% level of confidence here, okay, notice that the width of that interval is fairly small, okay? As you get more confident, notice that the width gets bigger and bigger and bigger. That's that whole idea of if you want to hit this little dot right there, how will you be the most confident that you get that little dot in your acceptable range? Do you want to have to hit it perfectly? Do you want this little target? Do you want it to be bigger? Do you want it to be bigger? Well, as your target gets bigger and bigger and bigger, your confidence increases. Okay, so this again is like the 90%, the 95%, the 99%. The bigger and bigger your target, the wider and wider your interval, the more confident you will be. Okay, so why does the confidence interval get wider as the level of confidence increases? Well, the probability that you capture the true parameter, again, that dot in the center there, increases as you allow more room to capture it. Okay? So in other words, bigger target equals more confident. But that also equals more room for error. Okay, you don't have to be as close to the actual value. You get to be further and further and further away. Okay, so there is a trade-off between the width of your interval and the confidence level. Okay, the higher the level of confidence, so the more and more and more confident you are, the wider, the bigger the confidence interval. Remember, you want that target to be bigger and bigger and bigger. Okay, so you can be really confident about your answer, but your answer isn't going to be very precise. Again, that's going to be that idea of a large margin of error. You want to be, if this is your target here in the middle, and you want to be confident you hit it, you're way out here, that's a pretty big margin of error. You could be way far away, okay? Or you can have a really precise answer, okay? That would be a low or small margin of error, but you're not going to necessarily be very confident that you can hit that little itty tiny bitty target. Okay, so there again is a trade-off. All right, the other thing to talk about, and this one seems to make a little bit more intuitive sense to people, is how does your sample size affect how wide your interval is? Okay, and hopefully, again, this one will probably make some intuitive sense. If you have a small sample size of, say, 30, and then you go to a sample size of 100 or a sample size of 1,000, it should make more sense, or at least it usually does to people, that the more and more and more things you sample, the more and more and more accurate your results are. Okay, so if you went and asked 10 people how they felt about something, and I went and asked 1,000 people how they felt about something, we could be more confident that I was closer to the real value about how people felt on that issue than you were, because I asked a whole bunch more people. And so therefore I should have more accurate results, which would mean a smaller interval, okay? Less error, if you will, a smaller interval. All right, so the larger sample size from a representative sample makes the width of the interval narrower, okay, or smaller. Larger samples are closer to the true population. So the estimate, whether that's a mean or whether that's your proportion, is closer to the true value than it would be for small samples, okay? So bottom line, if you need a high level of confidence, okay, which is again gonna make that error big, okay? I want a high level of confidence. I need that big target, but I need a low margin of error. Then how do we achieve that? And if that's the case, you need to increase N, increase your sample size. Okay, so if you want to be more confident generally, again, think about your target. More confident means I need a bigger and bigger and bigger target, which should be increasing your error, but you can counteract that by increasing your sample size. All right, so let's take a look here at some examples and see how we can put this into practice, okay? You compute a confidence interval with a sample size of 25. What happens to the confidence interval if you increase the sample size to 50? Okay, so do you expect as you ask more people, are your results getting more accurate or less accurate in terms of describing the population? Okay, so you should find that you are more accurate. Okay, more accurate means we're coming from this big to smaller to smaller. We're getting more and more and more accurate. We want to go in. Okay, this means this narrows the confidence interval. Okay, it's getting smaller and smaller and smaller. Instead of a range of here to here, now we're here to here. Okay, getting smaller and smaller and smaller. All right, you compute a 95% confidence interval. What happens to the interval, that is if you change the confidence level to 90%. Okay, so again, think about your target. Okay, if you were 95% sure you could hit that target, you might only be 90% sure you can hit that target. Again, we're getting more accurate, and so we're going to narrow the confidence interval. All right, two stat students each compute a confidence interval for the exact same parameter. Okay, student A uses a sample size of 40, student B uses a sample size of 30. How will their width of their confidence intervals compare? Okay, so I guess I'm going to rephrase it this way, especially for a video. Whose interval will be narrower? Who will have less error? Okay, I'm hoping you have decided that student A will have less error because her N is greater than the N for student A is greater than the N for student B. Okay, so student A's confidence interval is narrower than B's. Okay. All right, and last one here. Two stat students each compute a confidence interval for the same parameter. They use the same exact sample size. They both asked 25 people. But student A makes a 90% confidence interval. Student B makes a 99% confidence interval. How will the width of their intervals compare? Okay, so remember, 90% confident, if here's your target, you might be 90% confident here, but if you want to be more confident, I want a bigger target. We are going to the outside. Okay, so student B's confidence interval will be wider because, I don't know if it's a he or a she, we'll say it's a he today, because he has the greater level of confidence. Again, he's got the bigger target, okay? So his interval will be wider. All right, please go ahead and take some time to do the practice problems 1 through 6 in the pages that follow, and we are going to be posting those into the forum. So once you've answered those, go to the forum and post the answers you got and join in the conversation to see how it is we are all understanding confidence intervals.